Welcome back to Bell Numbers. This is part 2 of our Advanced Trigonometry series, and today we're exploring trigonometric functions. Have you ever wondered why sine and cosine form smooth, infinite waves, or why tangent shoots off into infinity? In this video, we're diving deep into trigonometric functions to master how they behave, how to graph them, and why they rule the mathematical world. Let's start with a classic question. What exactly is pi? Pi is simply the ratio between the circumference of a circle and its diameter. No matter how big or small a circle is, this ratio never changes. It's always 3.14, followed by an infinite line of non-repeating decimals. That's why we stick to the Greek letter pi instead of writing down an endless number. Now back to our unit circle. What's its total circumference? With a radius of 1, the diameter is 2. This gives us a total circumference of 2 pi. Measuring angles in 360 degrees is just a human convention. 2 pi, however, is a pure geometric fact. That's why mathematicians prefer radians. Instead of dividing a circle arbitrarily, radians measure the actual arc length along the circumference. So 90 degrees becomes pi over 2. 180 degrees is pi. 270 degrees is 3 pi over 2. And a full 360 degree turn equals 2 pi. From now on, we're ditching degrees and sticking purely to radians. Recalling our previous video, any point P on the unit circle has coordinates x and y. These represent the cosine and sine of the angle. Now let's plot sine on a graph where the horizontal axis is angle x in radians. At angle 0, sine is 0. It climbs to its maximum of 1 at pi over 2, drops back to 0 at pi, hits its minimum of -1 at 3 pi over 2, and completes one full cycle at 2 pi. This forms a smooth wave that repeats every 2 pi period. Looking at the unit circle, opposite angles have opposite sine values. So sine of -x equals minus sine of x. This makes sine an odd function, where f of -x equals -f of x. What about the cosine? It also forms a wave, but starts at 1, drops to -1 at pi, and completes its cycle at 2 pi. Just like sine, it repeats every 2 pi, meaning that cosine of x plus 2 pi n equals cosine of x. Now look at its symmetry. Points on the right share the exact same cosine value as points on the left. Therefore, cosine of -x equals cosine of x. Functions with this property are called even functions. As we know, the tangent is the ratio between the sine and the cosine. Its graph looks completely different. It starts at 0, but shoots to positive infinity as x approaches pi over 2, and to negative infinity as x approaches negative pi over 2. This creates vertical asymptotes at pi over 2 plus pi n. An asymptote is a line the curve gets infinitely close to without ever touching it. Why does this happen? Look at the limit as x approaches pi over 2. From the left, cosine is positive but getting extremely close to 0. Dividing by an infinitely small positive number forces the tangent to positive infinity. From the right, cosine is negative, driving tangent down to negative infinity. This exact behavior repeats at every asymptote across the domain. Every function has a reciprocal. For the main trigonometric functions, we have secant, cosecant, and cotangent. Let's explore secant using the unit circle. For an angle x, cosine is the horizontal projection. Now extend the radius to intersect a vertical tangent line at 1, 0. The horizontal projection of this new triangle is fixed at 1. This extended hypotenuse becomes 1 over cosine, which is secant of x. It literally shows how much we must stretch the radius, so its horizontal projection equals 1. At angle 0, secant is 1. As x approaches pi over 2, this stretching grows infinitely large, creating a vertical asymptote. Past pi over 2, the intersection shifts left, making secant negative. Now what about cosecant? This time draw a horizontal tangent line at 0, 1. Extending the radius to this line sets its vertical projection to 1. This length is 1 over sine, which is cosecant of x. Its graph mirrors secant, but shifted by pi over 2. Finally, cotangent. Using that same horizontal line intersection, cotangent is the x-coordinate, given by cosine over sine. Notice cotangent is 0 at pi over 2 and shoots to infinity as x approaches 0. While tangent grows larger as the radius gets steeper, cotangent gets smaller. Now you understand how these 6 fundamental functions behave. You are ready for the ultimate challenge, proving trigonometric identities. In our next lesson, we will unlock the core formulas to easily simplify any complex expression. Make sure to subscribe and turn on notifications so you do not miss it. Keep thinking, keep exploring, and I'll see you in the next lesson.